today's objective, 0 and negative exponents. Let's go over some definitions first, okay? Base, in a power, the number used as a factor. Exponent, in a power, the number of times the base is used as a factor. All right? Monomial, a number, variable, or a product of a number and one or more variables. So for example, 4, talking about the number, a variable, x, or you can have with both of them a coefficient and a variable. You could also have more than one variable. Alright, so that's what we call monomials. So let's look at the parts of a power. This whole thing, 10 to the third, is represented as a power. Okay, the 3 is the exponent of that power. And 10 is representing the base. Alright? So let's look at some patterns with exponents. Let's complete this table. You notice here I have 2 to the third, and that equals 8. Remember, 2 times 2 times 2. 2 is being represented as the factor, and so that is being multiplied. The exponent is telling the base to multiply it that many times. Okay? 2 squared is 4. 2 to the first is 2. Also, notice that when we get down 2 to the 0, that equals 1. And we notice this pattern. Have you seen it yet? Notice that we are taking half every time. So when we get to this, to 2 to the 0 equals 1, well, half of 1 is a half. And notice how the exponent becomes a negative 1. But that's the same as bringing the 2 down into a denominator's position. And that's no different than saying, 2 to the first, 1 over 2 to the first. Here, 2 to the negative, that's no different than writing 1 over 2 squared, which 2 squared is 4, so that'll give us 1/4. Alright, let's look at the 5s. So notice what happens here. 5 to the third, that's the same as 5 times 5 times 5. Well, 5 squared would be 5 times 5, which is 25. Notice what's happening here. All right, notice that pattern. Okay? What do you think is happening when I have 5 to the first? Well, if I'm dividing by 5 here, I'm going to divide by 5 here, so I get just a 5. Okay? Now I have 5 to the 0. If I divide by 5, that gives me a 1. Divide by 5 again, 1 over 5. So remember, keep in mind that when I have 5 to the 0, I get a 1. Just like I had 2 to the 0, I got a 1. Okay? So now, notice here, I have 5 to the negative 1, that gave me 1/5. Well, 5 to the negative 2, remember, I'm going to divide by this, so that means I have 25, which is also the same as 1 over 5 squared. But we know what 5 squared is, so we're going to simplify that. Alright, let's look here. 10 to the third. If you notice here, how many zeros does this have? It corresponds to the exponents. 10 squared, 2 zeros. 10 to the first, 1 0 with a 1 exponent. 10 to the 0 is 1. No zeros. Okay. 10 to the negative first, again, that's 1 over 10 to the positive first power. And we get down here, that's no different than saying 1 over 10 to the positive second power. Alright, and we know that 10 squared is 100. So if you notice a pattern, when I have 2 to the 0, when I have a 0 power, notice what that equals. That's one of our exponent rules. Okay? And then notice when the negative, notice what's happening. It's the same here, except they're changing positions. Okay? So some rules of exponents. For every non-zero number x, you have x to the 0 equals 1. We definitely saw that when we were talking about the table. All right, so let's just go over some examples. 1,115 to the 0 power equals 1. Now keep in mind here, my base is xy. So that whole thing is being raised to the 0 power. That equals 1. Negative 4.6, all of that is being raised to the 0 power. That equals 1. So whatever my base is, that being raised to the 0 power, that equals 1. Next rule, for every non-zero number x, so x to the negative a, so remember what we saw in the pattern, that this now becomes into the denominator's position, so it flips roles. So it comes down into the denominator, so that's 1 over x to the a. So let's take a look at this example. 5 to the negative 2. Well, again, the 2 will become positive when I change positions, so that would be flipping it now. So that's the reciprocal, so 1 over 5 squared, which we know simplifies to 1 over 25. Let's look at y to the negative 6, which is 1 over y to the 6. Keep in mind that when we take the reciprocal, that the exponent is now positive, okay? Let's look at this piece. When you notice here, what is my base attached to the exponent? The y is what is attached to that negative 4. If this whole thing was, then it would be written like that. That's not what we have. Okay? So 3x here is just going to come along, and this is what is going to be flipped. Okay? So no different than when I simplify, I would get that. Right? Let's do some practice. Let's simplify some of these. So I see 6 is my base. That is being raised to the 0 power. I know that that equals 1. Number 2, 4, x to the 0, y to the negative 2. Well, let's take this in pieces, okay? I know that x to the 0, I know that that's going to equal 1. So I have 4, x to the 0 is 1, and then this piece is what I'm going to take the reciprocal for. So remember that, it looks like that. So let's clean this up a little bit. So I have 4 over this. So now let's go ahead and remember that that's a whole number. So when I simplify that, that would give me 4 over y squared. Okay. Now, number 3. So I have negative 5x to the negative 4th. Negative 5 is not a part of my base. X is my base to the exponent. Okay? So I have to be real careful when I'm dealing. You know, the parentheses is going to tell you what is part of your base and how that exponent affects that base. So this negative 5, okay, is just going to come along, and we're going to take the reciprocal because I have a negative exponent. That exponent now becomes positive. All right. Let's go ahead. We're going to multiply straight across. So it gives me negative 5 and then x to the 4th on the bottom. Okay. All right, let's look at number 4. Same thing. So 2/3. This is my base. X is my base. Negative 6 is my exponent. It's negative. It tells me I take the reciprocal. Okay. Now I already have a fraction, so I'm just going to multiply straight across. 2 times 1, and then 3 times x to the 6 is just 3. 2 over 3x to the 6. And that is my final answer. Now notice here, we're used to seeing the negative exponents in a whole number's position, but this one is negative down at the bottom. So if the negative exponent is telling us to change positions, that means that this is going to come straight up to the top. So that would give me a 4 to a positive third. And when we start learning about cubes, you would have known that that would be 4 times 4 times 4, which is 64. Okay? All right. Let's evaluate. So I have A is 2, B is -1, and C is -3. So let's go ahead and plug in what our variables are representing. So A is 2, so that's 2 squared, and B is -1, and that is to the 0 power. Okay, so let's go ahead and work this. So we have 2 squared is 4, and here we have -1, but that is being raised to the 0 power. So we know the 0 power rule now, that equals 1. So when we simplify this, 4 times 4 is 16, times 1 is 16. Okay? Problem number 2. So let's go ahead and plug in what we know. We know that A is 2, and that is being raised to the -3. I do not have parentheses here, so I know that the A, which is now represented by the 2, is only being raised to the third power, to the -3 power. So this piece is what is going to flip, take the reciprocal of it, okay? Let's clean this up some. And I know that 2 to the third is 2 times 2 times 2, so that gives me 5 to the 8. All right, number 3. Let's plug in our values. So C is -3, and that is being raised to the 2, the second power. B is -1, and that has a -1 exponent. So let's clean this up some, okay? So remember, -3 squared, that's -3 times -3. So what's -3 times -? It's a positive 9. Okay. Then I have -1 being represented with, my base is -1, but my exponent is also -1. So that is going to come up to a whole number's position. So when I multiply this together, 6 times 9 is 54, multiplied by -1 gives me a -54. So this piece here came straight out. Okay? All right, let's plug in our values here. So -2, and then A is +2 raised to the -3rd, and B is -1 being raised to the -2 power. All right? So this 2 does not have a negative exponent attached to it. So that can just stay. This one has a -3, so that is going to change positions. We're going to take the reciprocal of that. So that goes down into the bottom. This one, same thing. All right? So it's -1, so that goes down into the bottom with a +2 exponent. Okay? Now, keep in mind, let's clean this up some. So we have -2, and then this simplifies to an 8. And then -1 times -1 is a +1. All right? So now we have -2 times 1 is just -2. Then we have 1 times 8 times 1, which is 8. So when it's all said and done, that's -1/4. So from this, we know that with the negatives, they're going to flip. They're going to change positions. If they're negative in the bottom, they come up into a whole position.